Welcome everyone to my LeetCode weekly contest 428 live stream. If you're here for solutions, jump ahead to 90 minutes in or use the timestamps in the video description. In a few moments, we'll be doing the contest live, we'll be answering questions and giving hints in the chat. So make sure to come join us every weekend for the contest. No code will ever be shared while the contest is running, but immediately after it ends, we will go through solutions for all 4 questions. So make sure you stick around. If you enjoy LeetCode content, do check out the rest of my channel. I have videos on different problems as well as hardest question 4s of previous contests. And as usual, like and subscribe to stay up to date on new videos. Alright, contest is about to start in 3 minutes. Let me see who's around today. Okay. I think people are starting to stream in. Welcome to the channel. If you're new to the channel, welcome. I stream every Saturday night, Saturday morning, Sunday morning, depending on which part of the world you're in. Hopefully there's a time slot that works for all of you. I stream all the bi-weekly contests, and when there's no bi-weekly contest, I will stream the weekly contest. So make sure you come by and do LeetCode together with us. It's 2 minutes until it starts. We're just gonna hang out for a little bit. I was working on the let me see, the daily problem. This is the daily problem. Daily problem is pretty interesting. There's a school with a class of students, and each class will have a final exam. Yeah, I'm trying to keep my streak up. So my streak is 6 right now, which is actually now that I look at it, actually it's pretty bad. My maximum streak was almost 100. So I was spending, I think for first 3 months of this year, I managed to do every single daily problem every day for 3 months. And then I broke the streak, and after that it was hard to recover once that streak was broken. But I'm gonna try to get my streak up again. In the meantime, I'm gonna try to do a little better this contest. The last 2 contests were not terrible. Well, the last one was not terrible, but the ones before that, I think I did really badly. Let me check what I got. The last contest. Okay, at least I got some rating back. I'm trying to climb back to 2,000. So it was 2,000 for a while. Hopefully I can get back there with this contest. Oh, fingers crossed. Alright, I see some people started coming in. Welcome to the channel. Welcome. If you're not familiar with the channel, we do the contest live, but we don't show code live. That is why sometimes it will look like I'm doing nothing on screen. That's not because I'm doing nothing. I'm actually coding on a different screen. I want to make sure that to preserve competitive integrity, we don't show code. We also don't copy paste code in the channel or off channel somewhere else. We will talk about how to solve the problem, but you must write every line of code yourself. And that makes sense too, you know. LeetCode is pretty enthusiastic, I would say, in the way they enforce the competitive honesty rules. So we're gonna make sure we don't run afoul of that. Alright, contest is about to start. Alright, good luck everybody. Oh, 3, 4, 5, 8. So I'm gonna try and finish the first 3 questions today. So last one, 8. Maybe it'll be a bit harder. So question 1, button with the longest push time. You are given 2D array events, which represents a sequence of events. Okay, so 2D array, basically time index time pairs. So list of index time pairs. Press button number index at time t. Okay, we're looking for the button that took the longest time to push. If multiple buttons have the longest time to push. Okay, not the last button pushed. Not the last button to be pushed, but I think it's the longest time between pushes. Press at time 5. Oh, okay. So basically, you press button 1 at time 2, and then button 2 at time 5. Is that right? Yeah, button 2 at time 5. So you basically took 3 seconds to press button 2. So it's this one minus the one before. And then the first one will be 0. First one is 0. Okay. And there's at least one event. So if there's only one event, if there's the only event is like button 10 at time 5, then that would by default be the longest one. So the time it takes to press the first button is... Yeah, I don't know if I really understand this correctly. Time to press a button is different in time between consecutive button pushed. Okay. Yeah. Looks about right. Okay, welcome for those who just joined us. Remember that I don't code on screen, or at least I'm not intending to. So if you have questions, if you need help, make sure to talk in the say something in the chat, and I'll come get to you. If not, okay, so if multiple buttons have the same longest time, return the button with the smallest index. This is kind of important. If you don't watch this carefully, you might end up losing 5 minutes on your time. So make sure you check your work carefully. Yeah, that's something I always run into. I don't check my work for the corner cases. I run, which is not a bad thing in real life, but in a contest, it's not gonna work. Okay. Show answer? No, I can't show. We don't show answers on this stream. So you have questions, you should ask on chat, but we don't show answers on the stream. We don't show code on the stream during the contest. But if you want answers, make sure to stick around. At the end, we will talk about it. But try to work on the problems yourself first. Try to work on your problems yourself first. All right. Alrighty. I'm trying to be very careful here because in the past I always I submit too quickly and I run into I get penalized 5 minutes. So I'm very careful now. You're given a string initial currency and you start with 1.0 of initial currency. You're also given 4 arrays with currency pairs, strings, and rates, real numbers. You start currency to target currency. Oh my god. 4 arrays. Start currency, target currency I at the rate of rates 1. So you're given 4 arrays with pairs and rates. Why is it 4 arrays? Wait a second. Is it 4 arrays? Rates 1. Oh, they're only 2 days. Okay. So each target currency converted back to start currency at a rate of 1 divided by rate. You can perform any number of conversions using rate 1 day 1, followed by any number of conversions including 0 rates on day 2, and then return the maximum amount of initial currency that you can perform after performing any number of conversions of both days in order. Okay, so you can perform any sort of conversion you want on day 1, and then any sort of conversion you want on day 2. And then at the end of day 2, okay, so this may sound confusing. Basically, it's 2 days. Day 1, you do any number of conversions you want. And then day 2, you do any number of conversions you want. And then you find out which is the best currency. So day 1, these are pairs. You can go from Euro to USD at Euro to USD. Rate of target. Rates of target currency. Okay, I don't understand this. So Euro to USD. Okay, you start with 1 Euro. You go from Euro to USD. Okay, so Euro to USD, you get your rate is 2.0. So 1 Euro becomes 2 USD. And then 1 USD can become 3 Japanese yen. So Euro to USD, you get 2 USD. 2 USD to Japanese yen, you get 6 Japanese yen. Okay. And then pairs 2, you go from Japanese yen. Okay, so basically what you want. Yeah, and you can convert this multiple times. If this is like currency A to B, B to C, C back to A, and then you can go in a cycle if you want. Okay, if you go in a cycle, you might end up with infinite. That's my problem. There will be no contradiction in rates for either days. Okay, so basically it sounds like what you want is to convert from your currency to the most undervalued currency, and then from the undervalued currency to back to your currency on day 2. So that's the goal. That's the goal. Yeah. No contradiction or cycles in the conversion graph for either day. Okay, so there are no contradictions or conversion graphs. Okay, so that makes it a little bit easier. So it looks to me like some kind of graph problem. It looks to me like some kind of graph problem. So USD, Euro, Japanese yen. There's no cycles. There's no contradiction or cycles. So basically you need to find out how much, since there's no cycles, there's no cycle in the graph, which means that for each currency, but there can be multiple ways to get to the same currency. Let's say this is like I know, RMB or whatever, right? So there are 2 possible ways to get to euros. So you basically have to find out what is the maximum number of, so let's say for $1 or whatever the starting currency is, you need to find out based on day 1 what is the maximum value you can get for each of these guys. Okay, you want to find out what's the maximum value you can get for each of these guys, and then once you've done that, you want to find out for day 2, based on each of the maximum value, you want to convert back to USD or the starting currency. What is the best what's the best rate that you can get? Yeah, I think this is basically a graph problem. Yeah, this is basically a graph problem. Okay, let me think about how to solve this in a nice, comfy kind of way. If I'm aiming for 3 questions, I should have plenty of time to try and solve these questions. So I'm trying to make sure I do them well. So it's some kind of graph problem. And so there are only up to 10 currencies. There are up to 10 currencies, which is not a problem at all. Okay. Okay. For Okay, so there are no questions in the chat. This is a very quiet chat. Remember, if you have questions, ask in the chat. If I look like I'm not doing anything, that's because I'm coding away on a different screen. So don't think that I'm AFK. I'm not. Feel free to ask questions in the chat and I'll get to you. Okay, so this is something I just realized, which is the conversion is bidirectional. You can convert from start currency to target currency at a rate of this, and you can convert to the at a rate of 1/rate. So I was wrong about this. You're not allowed to have this because the graphs are undirected, and for an undirected graph, cycle means anything that's more than one path. So you can have something like this, RMB. Yeah, you can have something like this, but you cannot have the first version. Okay. Hey, BK Maya. Welcome. I'm good. Doing question 2 right now. Question 2, it looks like graph problem to me. So that's how I'm going to tackle it. Looks like graph problem of some kind. So we probably want to calculate the conversion rates. Yeah. Do you just join us? Are you in the contest today? I hope things are going well with you. I got a slightly easier way to do what I was initially planning to do. Yeah, question 2 is not difficult, it's just very convoluted. So it takes a bit of patience to do. If pairs 1, psi, equals to car. V equals pairs I1. It's just annoying to do. Yeah, I think question 2 is not hard. It's just very annoying to do. I'm not having a good time doing it right now. Huh. Alright, let's run this and see what I got. Pairs 1. Alright. Run. pairs 1 run. All right. Okay. Okay, so once you created the sort of conversion table, it's a matter of finding the best rates. You just go through which ones you can convert to, give you the best rate back, and that should be quite straightforward, I think. Okay, target currency. So there's also an initial and a target currency. Target currency. All right. This is a very quiet chat tonight. Remember, if if you're not seeing anything, make sure to talk on the chat. I think what's happening. Let me see. So sort of like day one. Let me see if I can get understand the logic behind this a little bit. So day one, what you do is you convert euro to USD. Your initial currency is euro. Euro to USD. To get 6 USD. And then USD is Japan to get 6 Japanese yen. Okay. Then day 2, you convert Japanese yen back to USD to get 24 USD. Where is Japanese yen to USD? Okay, Japanese yen to USD. Okay, I got a bug in my code. Let me see if I can debug this properly. Okay, I think I know what it is. Let's run it again. Okay, let's see if this works. Okay, are the answers supposed to be integers? Wait a second. Oh, they're not supposed to be integers. Alright, let me just run this to make sure it works. I think this is correct. I think I got it. 1.5 and 1. Alright, submit. Freak. Something's wrong. Okay, not good. I got a bug. 671 out of 767. And I'll share what my submission says. 671 out of 717. Okay, so this is my bug. So this is a test case I failed. This test case right here. So I started AA, U and PP, and then AA and YL. So this is 4.7, 6.4, and then AA and YL is 1.8. Let me see what my answer was. Oh, straight up wrong. Why is it straight up wrong? Okay, so A to U is 4.7, U to PP is 6.4, and then A to YL is 1.8, and then this is day 2, AA, U, P, PP and U, PP, and then PP and YL. Okay, so AA to U is 1 over 2.6, and then U to is 1 over 3.7, and then PP to YL is 1 over 1.3. Okay, so let me see. There's something wrong. So what I'm doing is I'm calculating the conversion rates each way. So this should tell me A to U should be 4.7. A to U is 4.7. A to YL is 1.8. A to PP Oh, I didn't get A to PP. Why is there no A to PP? A to U. U to PP. There should be a U to PP. Okay, some bug with my program. I'm going to have to debug a little bit. Okay, so U and YL, okay. U and YL. Then U and YL. Let me see. There should be a U and PP. Okay. Okay, 0 and 1 found back I equals to 2. YL back I equals to 2. I don't get it. Why is it not showing up? Okay, that's fine. Ah, okay, got it. I think I know what the problem is. 289.3630. Okay, cool. I think I got it. That was a stupid bug. Hopefully this time it'll be good to go. Okay, submit. Oh, another wrong test case. Damn it. Okay, I'm going to show my wrong test case. So people in the past have told me that I should show my wrong test cases. So this is my wrong test case, this N over here. This is the one that I'm having some problem with. Yeah, I'm still working on 2. I'm still working on question 2. Question 2 is not backtracking. It's just you build a graph, you find out the rates of each number from its source, which is the initial currency. And you find out the most profitable currency that you want to convert to, and then convert backwards. All right. I'm still fixing a bug in question 2. So hopefully I can get it done and move on to question 3. So let me see. So this is the bug that I have. I have N H H O T I and O T I F N T. Are these real currencies? Does anybody know? N H H O T I O T I F N T. So 1.7, 3.9, 8.8, and then on the back I have H O T I N and N F N T. So 1 over 1.6, 1 over 7.5, 1 over 9.5. Okay, let me check if my math is correct. Okay, 1.7 times 3.9. This should be 6.63. So this over here should be 6.63. Let's see what was the answer that I got wrong first. And then from here, 6.63 times 8.8. Equals to 58.344. 58.344. Okay, so here, 1 over 1 slash 0.15. Okay, so if I convert to H, I get times 1.7 divide 0.6.6. Oh, that's a pretty bad deal. Divide 0.6.6 and then times. Wait, this is a really bad deal. Okay, this looks like a really bad deal. So it starts from N, right? Oh, it starts from N. This is H. Okay. N H H O T I O T I F N. Okay. So N to here. Let's see. So N to here will be times 7.5. N to H 6.6. So I should convert from N to H. Okay, something is wrong. My missing an H. Where's the H? O T I H. Okay. Okay, finally accepted. Oh, it's just that took a while. Gosh darn it. Okay, question 3. Finally. Count beautiful splits in an array. Are you guys talking about Warsaw flight for question 2? No, you don't need Warsaw flight at all. You just have to figure out what is the ratio. Yeah, I'll explain 2. Let me explain 2. Okay, cool. Let me explain 2. So, the basic idea is that you have a bunch of currency conversions, right? You have your source currency and your target currencies. And you want to convert from source to target. Yeah, it tells you all the possible pairs of conversion on day 1, and then all the possible pairs of conversion on day 2. Okay? So essentially what you want to do is you want to calculate, essentially what you want to do is you draw a graph. So for instance, take this first example. You don't need any sort of shortest graph. You don't even need a real actual graph algorithm. You need to think in terms of graph, but you don't need to use graph algorithm. So euro to USD, USD to Japanese yen. So euro to USD, rate is 2.0. So 1 euro can become 2 USD. And then 1 USD can become 3 Japanese yen. So 2 times 3 is 6. 1 euro can become 6 Japanese yen. So basically what you want to do is, you want to find out on day 1, if you want to convert from euro to that currency, how many of that currency will you get? So on day 1, if I convert from euro to Japanese yen, I'm going to get 6 Japanese yen. 1 euro is 6 Japanese yen. 1 euro is 2 USD on day 1. How do I get that? Well, you do essentially your breadth-first search over this list. So you start with euro, you sort of construct this graph, and then you find out for each currency, each target currency, how much does 1 euro equals by traversing the graph. Okay? And then you do the same thing for day 2. You have euro, CHF, which is franc. And then, where's the USD? There's no, there's a USD. And then Japanese yen. So in this case, 1 euro is equals to how many CHF? So CHF to euro is 6, right? Euro to CHF is 1 over 6. 1 over 6. 1 euro equals 1 over 6 CHF. Because of this, CHF to euro is 6. So USD, 1 euro to USD is how much? Well, let's look at CHF. USD to CHF is 5. USD to CHF is 5. It's 1 over 30. Am I right? Yeah, it's 1 over 30. Okay? And then Japanese yen is Japanese yen to USD. So 1 Japanese yen is equals to 4 USD. So 1 Japanese yen is equals to 4 USD. So this is of 1 over 120. So basically what you want to do is you take this and you divide by this. You take this number, divide by this one. Right? So you look at each of these numbers and you compare. So from 1 euro, you can turn that into 6 Japanese yen on first day. And then from 6 Japanese yen, how many euros can you turn that into? You divide by 1 over 120. So it's 720. You get 720 euros back. So Japanese yen is your best target currency. So idea is you calculate the rate from your base currency to everybody else. You find out the best rate by dividing day 1 and day 2. So day 1 divided by day 2, you actually get 720 Japanese yen back. Yeah. So that's the basic idea behind question 2. You don't need a priority queue. You don't actually need Warsaw void. Because there are only 10 currencies, you can do it in the dumbest, most brute forcey way ever. I actually did it using for loops and nothing else. And you can do that too. Yeah, I hope that was useful. I'm going to go on to question 3 because I'm a little bit behind. Actually, I'm super behind. Count beautiful splits in an array. You're given an array nums. A split of an array is beautiful if nums is split into 3 non-empty subarrays, such that nums can be formed by concatenating. Okay. The subarray 1 is a prefix of 2, or nums2 is a prefix of nums3. Oh boy. Okay. So you want to count the number of ways you can make this split. Oh boy, it's that kind of question. I don't think I'm gonna finish. Try my best. Okay, so basically you have an array. You want to divide it into. This is nums1, nums2, nums3. So you have a pointer I, like let's call it A and B. A is the start of nums2 and B is the start of nums3. And 0 is the start of nums1. And they cannot be empty. They cannot be empty. Okay. So let me see how big is this first. So the length is 5,000. So we can do some for loop shenanigans. We can actually do a for loop. Can we do a for loop? We can do some kind of for loop. So let's see. Nums I. Oh, this is very suspicious. This is very, very suspicious. This tells me that I can use this nums I somehow to help me. Okay, so basically, if it's basically I need a quick way of finding out whether whether this nums2 is a prefix of nums3. How do I tell if it's a prefix of nums3? And it says here nums1 is a prefix of nums2, such that nums can be concatenating. Yeah, nums2 is a prefix of num3. So either nums1 is a prefix of nums2, or nums2 is a prefix of nums3. How do I find out if an array is a prefix of? How can I find out if an array is a prefix of another array? Like a subarray is a prefix of another subarray. Because they can be in the most extreme case, they can be 1 1 1 1, right? If they're 1 1 1 1, then that's gonna suck. Oh, actually, I can do like a prefix sum. I can do a prefix sum because interesting. I can do a prefix sum because this is 50, right? I can do a 2-dimensional prefix sum. Oh, I can do a 2-dimensional prefix sum. 0, 1, 2, 250. And then what I do is, if I want to know if this and this is a prefix of this, how do I know if this is a prefix of this? Oh, if I want to know if this and this two is if like this is a prefix of this, all I have to do is to go to here. This is length L. I have to go to L, length 2L. I take this. This should be double this. Can I do that? Oh, I can't. Oh, I cannot. Cannot do that. Cannot do that. That's not gonna work. Because these things can be different order. So this I can like 1, 6, 8. Yeah. No, this doesn't work. Yeah, originally I was thinking of prefix sum. Prefix sum. Okay, that doesn't work. How do you tell then? How do you tell if one subarray is the prefix of another subarray? Okay, let me read my chat. Sorry. Let me read my chat. Okay, look like BFS, priority queue, normal queue. You don't even need a priority queue. So you can actually do brute force. You just do a for loop. You literally just do a for loop. Every time just check. Because there are 10 currencies, right? So you check currencies 1 to currency 10. You check currency 1 to currency 10. You know, there are only 10 currencies. Let me show you guys. There are only 10 currencies. So if you want to calculate, you just check currency 1 to currency 10. You don't even need like priority queue or for loop. You don't even need an edge list. I just use brute force. All you need to do is calculate the ratio of whatever this is. You start is like a depth first search or breadth first search, right? You start with euro, which is the initial currency. You calculate everybody who is directly connected to euro, and then you calculate everybody who's connected to those other people, and so on and so forth. You spread out like breadth first search, essentially. You breadth first search, and then using breadth first search, you sort of calculate the rate, everybody's rate, with in conjunction to a euro. Okay, so how do you calculate? How do you know if something is a prefix of another thing? In like O1 time or something. Well, what you could do is you could have like you can have a lookup. So one thing that can make it faster is you have a lookup. Yeah, I'm gonna try something because I'm running out of time. Basically, what I want is I'm gonna have a lookup. Lookup 0 to 50, and these are the indexes they occur. I'm gonna start with this, and then let's say this index is 0. I'm gonna go to all the other indexes that are 0, and then check those. Okay, I'm gonna start coding. I'm gonna start coding because I'm definitely running out of time. And let me just check my chat one more time. Let me see. Priority queue initialize in elements of both should be equal. What if the sum are equal for more than 2 subarray? What do you mean by the sum are equal for 2 subarrays? Oh, you mean the prefix sum? Yeah. So prefix sum doesn't work. Yeah, prefix sum doesn't work. Both array sizes are equal. So you can do that. So you check that. You yeah. So the problem with that is that you end up with like on time. Yeah. So that's not good. On time is that's gonna be bad. So you should not end up with on time. Yeah, I'm just gonna try brute force for question 3. I'm pretty sure it's wrong, but I just want a brute force solution. Uh I just want to put a brute force solution down in the books, and maybe his brute force will work. I have no idea. I'm just gonna try brute force for question 3. Brief approach for question 2. Okay, all right. I'm gonna go to question 2. Yeah, so please don't say things like question 2 was too easy. I think this is a very inclusive channel. Let's try and not be judgmental about whether questions are easy. I think it is always subjective. So I'm going to avoid making claims like that. And everybody's learning, so let's try to be encouraging. So the basic approach is you want to do day 1 and day 2. Day 1, you want to say, if I have €1, one initial currency, €1 or whatever initial currency on day 1, how many of each currency can get? So this is basically a breadth first search problem, right? You have the vertices and weights of each vertex of a graph, right? These are the vertices and weights for day 1. You want to convert it to something like this. You do a breadth first search. You start with euro, €1, and then you say who is euro connected USD. So you have 2 USD, and then 3 whatever. You do all the neighbors of euro first, and then you do all the neighbors of these neighbors. So that will give you 6 Japanese yen, right? USD Japanese yen is 3, so 3 times 2 is 6, right? And then you repeat the same process for the second graph. So €1 gives you 1.16 or 0.15 franc. And then franc to USD is 1/30. USD to Japanese yen is over 1/120. So what that means is that when you convert backwards, you take this number, divide by this number, or this number by divide by this number. So once you have the sort of conversion rate, you want to find the most overvalued currency and then convert to that guy and then convert it back. So how do you find the most overvalued currency? You take this number, divide by this number. So Japanese yen 6 divided by 120 will give you 720 euros. Euro 1 divided by 1 is only 1 euro. USD 2 divided by 1 over 30 will give you 60 USD. So euro, you can turn it to 2 USD. Day 2, you can turn it into 2 USD and 60 euro. Yeah, so that's the basic idea. So you calculate the rates. It's a graph problem. Okay, I gotta work on question 3 a little bit. I hope that was helpful for question 2. Question 3. Question 3. I need to figure out. Basically, you want to divide in 3 arrays. Nums1 is a prefix of nums2, or nums2 is a prefix of nums3, and you count how many beautiful arrays there are. I'm still working on question 3, but let me work on it a little bit more. And come back and help you guys if I can. Okay. Just draw out a little bit to help myself. List and int. Index our range. Okay, let me see what's cooking on the chat. You tried brute force. Try all possible split. Yeah, inner loop check for prefix or not. Increment and count. Yeah, that's what I'm trying. I'm trying brute force essentially. Kind of hoping that wait a second. Why is this Okay. 0 and 2 and 0. Okay. Let's submit. I don't think this will work. Pretty sure this will not work, but let's see if I get lucky. Index our range. Okay, a equals 0, b equals 3. Okay, what's the largest? So if we have a and b, what's the largest it can be? The largest nums 2 can be. Let's see. Okay, let me see. A equals 0. A equals 0, b equals 3. A equals 0, 1, 2, 3. Why is this? A. Oh no. So a equals 5 equals 0, 1, 2, 3, 4, 5. 5, 6, 7. So this is 8. 8 minus 7. No, 8 minus 5 is 3. Minus 5 is 3. Okay, sorry. Let me look at chat again. Yeah, brute force steals TLE. Yeah, I'm trying to. I'm also trying to brute force. I want to get at least the brute force in the books, but I'm pretty sure brute force will not work. B minus A. Is to run. Okay, 0 to 8. Let's see if this is correct. Index our range. There's a bug. 540 over 583. 540. Q2 was not a Q. Yeah, you know what? Alatagi. Yeah, it is. It is always funny. You can tell. Yeah, Raihanu Bari Tanvir, welcome back. Good to see you again. So Baliram Gupta, I'm going to try question 3. I'm also trying question 3. Like always fun. I'm also using brute force. I think the brute force, brute force. I think it's not. I'm not having a lot of luck. But who knows? Who knows? Yeah, I got a weird bug. Okay. Okay, let's see. So I got a weird bug. Yeah, you know what? Question 2 is not always question 2. Well, so 8 more minutes. Good luck, everybody. Since everybody is here, I'm going to take this chance to do my usual plug, which is if you enjoy this channel, it'll help me out so much. You just click the like on the screen of this stream right now. It's gonna help me out a little bit. If you enjoy my channel, and only if you enjoy my channel and you want to come back next week, make sure it's like and subscribe. Subscribe to my channel so you know next time I'm streaming. I stream every week. I stream all the bi-weeklies, and if there's no bi-weekly, I will stream the weekly. Usually, I'll stream only one contest a week. But if you enjoy what I'm doing, make sure you come back next week. I'm also going to try out to put out more videos like other than my live streams. So if you like that, leave a message and comment to let me know what is it that you enjoy, and and yeah, basically I'll try to put out more of that kind of content. So nums1 is prefix. Yeah, nums1 is also pref. I equals 2 also prefix. So 1 2 3 4 5 6 7. Yeah, this is correct. I equals 3 1 2 3. Okay, having some kind of bug. Yeah, I'm not sure what's the best way to make this faster. I'm also thinking really hard, to be honest. 0 1 2 3 4 5. Okay. 1 2 3 4 5 6 5. Okay. 6, 7. Yeah, I don't know why this is 9. Interesting. Why is this 9? This is 19. Ugh. Yeah, I wonder why this is 19. What did I do wrong? Did I calculate something wrongly? No, it looks correct. Yeah, well, it doesn't look like I'm going to get question 3, unfortunately. That's not fun. Question 2 is simple Dijkstra. You don't need Dijkstra for this. You really don't. Question ON cube. I don't know. You know, Raihanu Baritanvir. You know, the truth is, it doesn't matter whether it's n cube or n square. N cube might work because you look at the number here is like 5,000. So in theory, n cube might work. But the thing is, okay, yeah, but the thing is, it's not about n cube or n square at this point. Is you need to actually know what the algorithm does, right? Sometimes faster, sometimes slower. Yeah. Yeah, and I don't know whether it's acceptable or not. I feel like the brute force is not working out for me. That's what I can say. So I'm having problems with brute force. I feel like, so here's what I'm thinking. I feel like this is something that you can do to help. That can help you. So num's I is less than 50. So this has to be something that helps you. It has to be. There's no way this is not gonna help you. Yeah. Okay, well, 58 is we're almost done. So Shashank Kumar Pandey, can you live stream on weekends for competitive programming? Yeah, so I'm live streaming. I do the LeetCode weekly and bi-weekly contests. I do the bi-weekly contest when there's round. I do the weekly contest when there's no bi-weekly contest. Yeah. What is the... Yeah, I'm kind of stuck on question 3 also. There's one test case I don't quite understand. So I'll show you guys which is test case I don't understand. So this one, it says that the answer is 19, but I only counted 18. I only counted 18. So the 18 I have is like a 0. So the 18 I have is 0, 0, and this can be any split. So this is like 9 different ways to split this. 3, 4, 5, 6, 7, 8, 9. So there's 9 different ways to split this. 0, 0, 0, 0. So there are 7 different ways to split this. And then I have this one way. And I have this one. So this is 18. I only count 18. Yeah, I only count 18 different combinations for this. It says the answer is 19. I don't know why it's 19. I gotta be missing something. I have to be missing something. These are 3 non-empty. All prefix nums2 is a prefix of nums3. Yeah. Well, the contest is over. Ay. I think I got a really bad rank also. I don't even dare to look. I hope you guys did well. Hey, Nash, welcome back. 3.4k rank. Well, I'm too scared to see my rank. God. I think it's gonna be really bad. Yeah, I also got 3,000 rank. So that's not good. And sometimes you get worse. Ha. Yeah, so Saknik San Sama, 2 out of 4, almost Q3, but better than last week. You know what? As long as it's better than last week, you're winning. As long as you do better than last time you tried it, you're winning. Right? Okay, cool. So the contest is over. Thanks. I am going to go through the questions that I've done, which is only 2 of them. 3 of them, I'm going to talk about question 3 also. I didn't get a chance to look at question 4, so I don't think I can talk about that. Let me take a swig of water, and then we're going to go through all of them. So make sure you stick around. But before that, as usual, if you enjoy the content, it will help me out so much. You like the video, you leave a comment on the VOD when you see it. Tell me how you guys did. I would love to see. I would love to know if you guys did better than me, or if you guys found a way to do question 3. Make sure to put in the comments also. Otherwise, we're gonna. Oh, Rahainu Baritanvia 1692. So do you do 2 out of 4 questions? That's very nice. Good job. Yeah, it looks like you may have done 2 out of 4 questions, but very fast, right? That's my guess. Okay, cool. Let me go on to the next part, which is discussing solutions. And this is for the YouTube. We are discussing solutions for LeetCode Weekly Contest 428. Jump to specific questions using timestamps in the video description. Please check out my channel if you enjoy LeetCode content. Like and subscribe to stay up to date on new videos. Alrighty. Let me just go through each of the questions in turn. We're gonna go through all of them. Starting from question 1, which turns out was not the easiest. So question 1. Button with the longest push time. You are given a 2D array events, which represents a sequence of events where a child pushes. Let me make sure where the child pushes a series of buttons on the keyboard. For each event I in the index time, indicate the button at index I was pressed at time I. So, for instance, 1, 2, this 1, 2 here, means that button 1 was pressed at time 2. So these guys are all sorted in increasing time. And time taken to press a button is the difference in the time between consecutive button press. The time for the first button is simply the time at which it was pressed. So the time for first one is 2. The time for the next second one is 5 minus 2, which is 3. And time for the third one is 9 minus 5, which is 4. 15 minus 9, which is 6. So you want to figure out which button was basically who has the longest duration. Yeah, who have the best duration. So the idea is very simple. You start with the first button, right? Button here is which button was pressed. So in this case, it'll be 1. Longest is, the best duration so far, and the last is the previous number that was pressed. The last was previous number of press. So the very beginning button is the first one, and the longest time you've seen is 2. So button was pressed, it took 2 time, and that was the best we've done so far, right? And then we're gonna go through the rest of the array, and each time what we do is we have the index and time. So let's say this is 2, index is 2, and then time is 5. Okay. the duration of this is the time minus the last one. So the last one is 2, right? Last is 2. So 5 minus 2, duration is 3. So button 2 was pressed for 3 seconds. Is it better than the last one? Nope, it's not. It's not even equal. I go on. If it's better than the last one, for instance, in this one 1 time is 15. The previous one is 9, right? So duration is 6. So 6 was better than everything else we've seen before. And then we'll set button to the index. We'll button to the button that was being pressed. And longest to the current best duration. The main thing to note is that if the duration is equal, we have to check that index is smaller than button. So the new button being pressed is smaller than the old button being pressed. Then we have to do this also. So this is the sort of little gotcha. If you miss this part, then you might have lost 5 minutes. I think that's all there is for this question. I don't think there's anything interesting. Yeah, yes, 2 only. Yeah, you solve question 2 faster. So you got a better score. Also, I have 2 bugs on question 2. Com-sci, I think I have to learn trees and graphs. Yeah, you have to learn trees and graphs. Are you a com-sci, like college? Are you in college? Are you a com-sci major? You probably learn trees and graph in year 2. So if you're still in year 1, then you gotta wait 1 year, or you can learn it on your own. It's up to you. All right. Question 2. Okay. Question 2. I didn't do it the most prettiest way. Question 2. Maximize amount after 2 days of conversions. You are given a string initial currency and you start with $1 of that currency. One of the currency. You're given 4 arrays with currency pairs and real rates. So the pairs are start to target and the rates are like rate. Okay? So the pair I goes with rate I. So pairs 1I. Pairs 1 0 goes with rates 1 0. Pairs 1 5 or whatever goes with rates 1 I. Yeah, they're not actually pairs. You can think of them as almost like triplets. So start currency, target currency, and rate as a triplet. Okay, so what can you do with these? You have 2 sets, pairs 1 and rates 1, and pairs 2 and rate 2. And what happens is you can, on day 1, use pairs 1 and rates 1 to do currency conversion from your base currency to any other currency you want. You can convert as many times you want. You probably want to convert to the sort of best currency. And then on day 2, you use the rates in day 2 to convert back. Okay? And because the rates in day 1 and day 2 are different, you might be able to make money. This is actually something you can actually do on the Forex, on the foreign exchange stock market if you're interested. It's called Forex trading, and people do make money from this. Obviously not as much as this problem suggests, but it's a real thing. You can perform any number of conversions, including 0, using the rates on day 1, and any number of conversions, including 0 on rates on day 2, and you want to come back to your initial currency at the end of day 2, and you want to have as much money as you can. Okay, so this, as you probably guess, is some kind of graph problem. Okay, but it's not. You don't need a graph solution for this. You really don't. You really don't need a graph solution for this. I'm going to sketch out what the strategy is like. Basically, what you want is you want to start with your base currency. Let's say euro, and you want to find all the neighbors of this. The idea is you want to find out for day 1 euro converts to how much of that currency. So what you want to do is you do a breadth first search. You start with euro, you find all the neighbors of euro. So euro's neighbor is USD. Okay, USD, and rates is you can convert 1 euro to 2 USD. 1 euro to 2 USD. So 1 euro gives you 2 USD. And then you want to find all the neighbors of the neighbors. So all the neighbors of USD. Who's the neighbor of USD? Well, Japanese yen, JPY. And this gives you a rate of 3. So Since 1 euro converts to 2 USD and 1 USD converts to 3 Japanese yen, you get 6 Japanese yen from 1 euro. So this is your graph for day one. You don't actually have to keep it as a graph. You can just keep it as a conversion table. So essentially, you know that euro is 1, USD is 2, and Japanese yen is 3. You don't even need this graph anymore. So what you do after that is you repeat the same process for day 2. Day 2, you start with euro again. In this case, euro CHF, right, is 6. That means 6 CHF converts to 1 euro. 1 CHF converts to 6 euro. So euro to CHF is 1 over 6, which is 0.15. Or 1 over 6. Okay? So 1 euro converts to 0.15 CHF. Okay? So, and then you have CHF to USD. USD. Okay? And you know the conversion rate between these two. From USD to CHF is 5. So this way will be 1 over 5. And then you multiply that by 1 over 6, you get 1 over 30. So 1 euro gives you 1 over 30 USD. And then from USD to Japanese yen is 1 over 4. So you convert, you basically multiply this again by this again. So Japanese yen is 1 over 120. Okay? So basically on day 1, you can convert 1 euro to 6 Japanese yen. On day 2, you can convert 1 euro to 1 out of 120 Japanese yen. In other words, you can take 1 Japanese yen gives you 120 euros. This is crazy. This is insane rates. So if you on day 1 convert 1 euro to 6 Japanese yen, on day 2 you can take the same 6 Japanese yen and convert to 6 divided by 120 or 720 Japanese yen. And so the maximum number you can end up with is 720. You can actually repeat this exercise. So in day 1, if you convert to USD, if I convert a rate of 1:2, on day 2, I can convert 1 USD to 30 euro. So 2 USD become 60 euro. If I convert to USD and then convert back on day 2, I get 60 euro. And euro, of course, if you don't convert, is 1:1. So the best number you have is this. You convert to Japanese yen on day 1, and then day 2 you go back to euro, you get 720 euro. Which is how you end up with this answer right here. 720. So basic idea is you convert this, you do this conversion table for day 1, do the same conversion table for day 2, and then you divide. You divide day 1's conversion number by day 2's conversion number and pick the biggest number. Right? That's the basic idea. How do you want to do that in code? Well, I did the most brute forcey way. To do is basically the neighbors. I do breadth-first search. R1 is the day 1 conversion rate. Initial currency is 1. This is a very standard algorithm. You say to do is neighbors. So for each neighbor, you go through. I didn't do any sort of stack. I didn't do Dijkstra. I didn't do anything like that. Right? The reason why I don't need to do Dijkstra is because this is an acyclic graph. There's only one path from any currency to any other currency. It's an undirected acyclic graph. So I don't need to do Dijkstra. There's only one path. There's no shortest path. So it's very easy, and I don't even have to turn this into adjacency because there's only 10 currencies. I just do a for loop every time. This is slow, but I don't care. It's fast enough. So I check each pair. If one of them is the current neighbor, then I will process it. I find what is the thing is target from U to V So from Euro to USD, and I check, have I found rate for this target already? If I have, I skip it. If not, I will keep calculating. I'll calculate a new target and add it in. So essentially what I get at the end of this R1, at the end of running this giant piece of code, R1 will be Euro 1, USD 2, Japanese yen 6. So I get all of these. Basically, I have a number for how many of each currency can I get from 1 euro. Okay? And then I'm going to repeat that for day 2. For day 2, I do repeat. I just copy and paste. You want to do it properly, you can write a function. Doesn't matter. And finally, what I do is I do for currency in R1. I take my best, which is R1, day 2 rates of the currency, divided by day 1 rates of the currency divided by day 2. That's what happens when I convert to it and convert back. And return my max. That's all there is to it. Let me see if there's any other questions. Yeah, I solved 2 and tried 4. Got wrong answer on test case 295. Yeah, well, that's Dashagani. I didn't even get to try 4. I was stuck at 3. That was very unfortunate. Yeah. Okay, so that's it for question 2. Let's move on to question 3. Okay, question. All right, question 3. I have a brute force solution, but it doesn't work. All right, question 3. Count beautiful splits in an array. You are given an array nums. The split of an array is beautiful if you split it into 3, nums1, nums2, and nums3, such that the 3 nums combine form array nums. So you gotta split it. You cannot have overlap. You cannot, have any missing numbers, right? You just split it into 3 parts. And the rule is either nums1 is a prefix of nums2 or nums2 is a prefix of nums3. So, the example we have here is, let's say 1, 1, 2, 1. Okay, so I'm going to split. I'm going to split into 3. nums1, nums2, and nums3. So if I have nums1 as this, nums2 as this, and then nums3 as this will work because nums1 is a prefix of nums2, and nums3 doesn't matter. I can also split it this way. So this is 1, 1, 2, and 1. So nums1 is again a prefix of nums2, and then nums3 doesn't matter. Okay? So these are the 2 possible ways I can split it. If I have something like this, then whatever I have in nums2 and nums3, this will not work. So the answer is there's only 2 splits. There's only 2 possible splits. This split and this split. This split and this split works. Any other split doesn't work. Okay, so that's the basic premise. So let me do another example. There was an actually in. So it's the other example I have is 0, 0, 0, 0. This is an actual test case. 2, 2, 0, 1, 2, 1, 2, 1, 2, 1, 2. Okay, so for this example, nums1, if nums1 is this, nums2 starts from here, and it can be anything. Nums2 can be this, nums2 can be this, can be this, can be this. They all work. So the sort of shortcut that you will notice is that if nums1 is a prefix of nums2, if nums1 is here and the prefix is nums2, nums3 can be anything else. So for instance, let's pick a different example. Let's say nums1 is 0, 0. As long as nums2 start with 0, 0, it can end anywhere else. You can end here, this will be valid. You can also end here, this will be valid. You can end anywhere else. So when nums1 is a prefix of nums2, the number of beautiful splits you have is n, the length of the array, minus 2 times the length of nums1. That's the way to think about it, because it doesn't matter where you cut, make the cut between nums2 and 3, all of them are going to be valid. If, for instance, in this case, nums so in this case, nums2 is not a prefix of nums1. Then what happens? Nums1 is not a prefix of num2. Then what happens is you have to actually count. You have to make sure that nums2 is a prefix of num3. So this would be acceptable because nums2 is 2 and nums3 is 2, 0, 1, 2, 1, 2, 1. Yeah. So I think the basic idea that I got to is I have some kind of is prefix function. I check whether these two things are prefixes based on their indexes. I essentially did a brute force. So I is range 1 to n minus 1. I is the start of nums2. And then first I check if nums1 is a prefix of nums2. Nums1 start at 0, nums2 start at I. Nums1 is a prefix of nums2. Then total plus equals to n minus 2 times I. It doesn't matter where I make the cut between nums2 and nums3, they're all valid. So this is a bit of a shortcut. If not, if nums1 is not a prefix of nums2, then I need nums2 be a prefix of nums3. Then I do another for loop, j, from I plus 1 to the n. And I want to count how many cuts I have. Yeah, and then returns total. This, unfortunately, does not work because it's a brute force and it's too slow. So I don't know what's the better way to do it. I tried doing like a prefix sum. You know, I look at this and this is very suspicious to me. It tells me that I have to use this information somehow. But I don't know what it is. Yeah, I couldn't manage to do this. So if somebody has an idea for how to do this, I would love to hear about it. Make sure you write it in the comments or chat, or actually send me an email. I'd love to hear from you. Let me know. Yeah, definitely let me know. I think this is it. Actually, let me just take a look at question 4 first. I didn't get to look at question 4 during the contest itself. Let me look at question 4 and see whether I have some kind of intuition for it. Okay, question 4. Minimum operations to make character frequencies equal. You are given a string S. A string T is called good if all characters of T occur the same number of times. You can perform the following operations any number of times. Delete a character from S, insert a character in S, change the character in S to the next letter in the alphabet. You cannot change Z to A using it, so it's not cycle. Return the minimum number of operations to make S good. Can you always make S good? Yes, you can always make S good. If you delete everything from S, S will be good. Or if you change S, every letter in S to Z, just to Z, or Z, everything goes to Z, is also going to make S good. Yeah, so I didn't manage to look at this problem during the contest. I don't have the answer for this. If you're looking for an answer, this is not it. I'm just going through the questions to explain what it looks like. So let's say S is ACAB. You delete an A. You end up with, okay. So this looks like a dynamic programming problem to me. This looks suspiciously like a dynamic programming problem to me. Because at every turn, you can either delete a character from S, you can insert a character in S. Wait, you can insert a character in S. Oh yeah, you can. Yeah. Or you can change the character in S to its next letter in the alphabet. So this is like a dynamic programming problem. Because they are letters, they are all letters. Yeah. So, it looks like a dynamic programming problem. So let's say A is 2, B is 1, C is 1. You want all of them to be equal. So what are the options you have? You can actually delete a character. You can delete an A. You get 1, 1, 1. Delete B, 2, 0, 1. You can delete C, 2, 1, 0. You can add, or you can rotate one letter to the next. Yeah, this one I have to think about it a little bit. I'm not sure what it is. I think it's some kind of dynamic programming problem where you sort of search, you have the search space, and then you hash these numbers. And generally what you want to do is you want to increase the numbers that are smaller and reduce the numbers that are bigger. Let me see. If you don't actually have the third one, it's much easier. You don't have this. This is much easier. So you just delete characters that are big, and then insert characters that are small. This one actually makes it more interesting. I think about it. I don't have the solution for this, but if anybody knows the solution or anybody can solve this, make sure to let me know in the comments. Tag me. I read and reply to all my comments, or you can send me an email. It's up to you. You can link something to your GitHub, or link something to your own LeetCode account. That would be much appreciated. With that, I think that's the end of my live stream for today. So thanks everybody for coming. I hope that you guys did well on this contest, and I will see you all next week. Thanks a lot. Bye bye.